roughly how old I am, doesn't it? Okay, well, welcome to the Correlation 1 Computer Support Specialist course. This is where we will begin to introduce you to IT information technology. So can we have a start? Let's have a start by a show of thumbs on the live chat for everyone that can see the slide that says Introduction to Information Technology. We will be using a thumbs up emoji quite a lot to let me know that you're all still with me and all doing really well. Okay, fastest fingers first comes from Sebastian, closely followed by Rasha, Mardi, and I apologize if I get any names wrong here. Marcos, gosh, we're cracking through. Pablo, Ronald, Paul, I was just reading a few out as they whip through. Okay, this is really good. Good to see you all familiar with using Slack. Certainly putting a thumbs up to Slack is literally what we'll be after for quite a few of these sessions. Okay, so let me trek through this and we will click through a few of these. This first lecture is really about embedding us in, getting us used to using some of the tools, and I'll go through some of the IT information. So what we're going to talk about is history of computers. Now, don't fall asleep. It's not really boring history. We don't go into a lot of details, but it's worth understanding where computers basically come from. We will talk about IT roles, where you may be positioned, the positions you may be drifting into after you completed this course, and what IT is really all about. And then we're going to talk about some IT fundamentals, so the job under fundamentals, understanding what you are likely to be drifting into, what you're likely to be responsible for, your responsibilities, and the technical job and functions that you might be doing when you gain yourself a position. As with all these courses, we are open to your comments. We're open to your questions. People will gain more out of this content if you ask questions. Please smash anything up in the live chat in your Slack session. If you have any questions, if you have anything you do not understand, please do come to us and ask those questions. It's not just me that will pick those up. We have Stefan here who's also going to pick that up. He's going to be our TA, our training assistant here. So he will be able to pick up your comments in there as well. And we will come back. You will get more out of this, the more questions that you basically ask, because it's my job to make sure you understand it. It's not my job just to bore you with PowerPoint slides, although we don't use PowerPoint really, but it's not my job to bore you with that. It's my job to make sure that you guys go away with the information that we're trying to get to you. So I guess any questions to start with? As we will drift into introduction. You will notice that my eyes will dart left, right, up, down. Okay, I've got a couple of monitors here. I run Slack on one system, so I can keep looking over there to keep an eye on what you guys are looking at, as well as the general presentations that we're running through. Okay, so introduction. So technology, tech, whatever you fancy calling it, there is a definition to it. It's basically defined as an application that uses scientific knowledge for practical use. Yes, these things are supposed to make our life easier, better, more enhanced. Okay, it's used basically to create or complete simple tasks, no complex tasks, all tasks, to basically make things simplified for us, to help us with both communication as well as the doing part of IT. So the types of technology IT is used across the mechanical world, across the medical world, across communications and electronics. Mechanical, we have everyone thumbs up if anyone's heard of products called CAD and CAM, which stand for computer aided design and computer aided manufacturing. Yeah, Sebastian's in there with that one. Well done. Yeah, so this is where computer is involved in the mechanical end of things, designing and creating items used in the car manufacturing, all the way down to basically doing your own 3D printing and creating items for creating little Lego pieces at some point. So I've got a friend a couple of doors down, creates his own little Lego pieces, design and beautiful. And that's all done through the technology end of things. Medical, yes, we are driving into the medical society here. There is a lot of medical stuff that is used for technology, not just in the analyzing things, but we all hear about AI nowadays, and we'll cover that a lot more towards the end, where we're doing things such as using AI in the computer industry to help us catch things like early breast cancer, to do the breast cancer screening and items like that. It's also used for training medics, so training surgeons on artificial environments, both with a virtual environment, to help them carry out operations in a virtual environment so they're not risking people's lives when they're training, learning how to do some of these complex operations. It's used massively in the communications industry. Of course, we all know that telephones now basically have drifted over to being digital. So we all talk about things such as voice, which is voice over IP. We do that later on in the course. But as you can see, it's used across an awful lot of different fields. So I don't think because you're going to get a job in IT that it's just going to be an IT field. It can be in any particular company across different platforms. So here's a fun fact. The term compute was never really about electronics in the first place. It's used from the 1600s. And it's basically first referred to as a person, not a machine, a person that did calculations. There's a famous book in front of you. I don't know if anyone would care to poke into the live chat exactly what that famous book is all about. God, it's probably a bit of a long title, isn't it, really, to put in there? But that first book was really designed, well, that book that's on screen was designed or was written about the ladies that basically did all the computing for the lunar missions. So these were people that were sitting in the background doing all the high-tech calculations by hand, because the computers in them days wasn't really that great, shall we say. It wasn't really that great. That's a bit harsh, isn't it, really, considering they put a man on the moon with it. But it was very true to say the computing power that we now are so familiar with. I've probably got more computing power probably in this watch, definitely in this phone, than they had across the whole of the lunar landing systems. Okay, so that kind of gives you an idea of how computing has expanded and how exciting that particular industry can be. So that's some definitions. Computer nowadays is defined really as an electronic device that can perform various tasks following a set of instructions or program, depending if you like to call it that. Okay, so it processes things, it does what it said, it follows a set of processes, a set of programs that tell it to do things. They're also designed so they can communicate with each other over longer distances. Certainly the wide area network that we're now familiar with, WWW, allows us to communicate across the world, and it also allows us to communicate out into space, because we are still communicating with Voyager 1, Voyager 2, and all those ones in the astral planes out there where they're still at. And that is basically still all driven by computer systems. It also allows us to handle a massive amount of media data. We talk about big data later on in the contents, but it's become more and more prevalent that we have large language models that require massive data stores. So it is all about, a lot about big data nowadays and how we manage big data. Now we'll go into that in a small amount of details, and we'll talk about cloud computing and other things later on in the class. But in general, this is a computer support specialist content, and not very specifically into some things such as our cloud computing, but we'll give you a damn good background to support those. So let's have a little discussion question. What do you do when your technology isn't working properly? You can put an answer into the live chat, or if you're feeling brave enough today, we might let you unmute yourself and you can have a little conversation. So what do you do if your IT systems, your technology, fails you? I'll give you a couple of minutes to type in there. I'll have a little drink of my tea today. One tea today, not coffee. Way too much tea. Switch it off and on again. Paul, it sounds like you've done frontline support desk already. So we've got Paul is turning it off and on again. Sebastian is restarting the device as well. Write a ticket for an IT support team. Athanis, I really apologize for that pronunciation of that name. That was horrible. I'll try again. Paul Bird. Okay, troubleshooting. Okay, troubleshooting. We do cover troubleshooting later on, but troubleshooting is a big area. That's a big topic that we can cover. And we talk about the key responsibilities of troubleshooting and how we get from essentially a problem, issue, depending on which way you want to define it, to the solution at the end of the day. A lot of people are unplugging it. A lot of people are troubleshooting, a lot of people. So we all have ideas about what we need to do when systems fail. But how much of an effect, honest is it? How reliable are we with our IT systems nowadays? I know certainly in the past, well, in the not so distant future, if this beautiful little handheld device that I carry with me everywhere, crikey, they're like attached to our hips nowadays. If that ever failed on me, crikey, and I couldn't get access to it, how would I know what was going on? How would I know about my calendar? How would I be able to talk to people? How would I be able to do those general communications that we do with not only audible communications, but also communications through the chat bots and chat windows, Skype, WhatsApp, etc., etc. Well, Skype's dead nowadays, isn't it? I heard recently that Skype was basically dropped out, so they're not going to support that anymore. But Teams and all that communication platform, email, crikey, how would that work? How would we manage without IT? I don't want to bring it into too much of a disaster, but I'm sure a lot of you have seen, what is it, The Walking Dead? Where they just lose all IT and the whole planet goes to pot? Yeah, pretty much it would be like that, wouldn't it? We are so reliant on IT, so it is critical that we keep our systems running. And indeed, the positions that some of you will be dropping into when we complete this course will basically be that in those positions where you help people to maintain their systems and help keeping them up and running, and you do troubleshooting to help people through these tricky times. Any questions on that discussion? Module C, check the basics, restart, error messages, update, test, restart, search solutions. Great load of things in there. We'll love chatting to you when we start doing troubleshooting. Call a hacker friend and try to figure it out. It's got to be good, hasn't it? Okay, so let's just drop into, you can't hear the audio. Can everyone else hear me? Okay, so we've got some audio. Seth, we'll get someone to drop in and try and give you a hand with the audio. If Stefan's about, he might come on and give you a hand there. Okay, so it's computer history. Don't all fall asleep. We're only going to touch history, okay? History wasn't one of my favourite subjects at school. It was sort of all right, but we got through it, didn't we? I think that was the way to do it. But it can be fascinating to understand where things are. So here's a question for you. Sorting out computer history. So let's see if you can have a couple of seconds, have a look at the items that we've got in here and place them in order. So we want you to put them in order in terms of when they turned up. I'll read out the items. So we've got Grace Hopper develops COBOL. COBOL, beautiful product. Bill Gates and Paul Allen for Microsoft. The computer chip is unveiled. Steve Jobs forms Apple. Steve Jobs and Steve Wozniak. God, that was a beautiful time, wasn't it? Wi-Fi was developed for the first time, so that's the Wi-Fi communication. Apple released the Apple Watch. And Alan Turing presents a paper on computable numbers. Oh, computable numbers. Mozilla launches Firefox. God, Firefox. I remember Firefox when I was younger. I will refer to me being younger quite a lot during this course. Bearing in mind, I've been in the IT industry for over 30 years now. Crikey, it feels like ages. So if you can have a little think and try and put those in order and then splash it up into the live chat window and we'll see what sort of results we have. Hopefully this will give Seth a chance to sort his audio out. Seth, let us know when things work. I sometimes find that the audio goes because I'm attempting to play it through a speaker that is turned off or something. I've got a couple of monitors here that I know have got speakers in. And sometimes within Zoom, I have to go into the settings which is the cogs menu. I'm doing this while you guys are thinking about what order the things are. Oh, come on. Boom. Fastest fingers first for you today, Cablan. We're expecting a lot from you. Well done. We'll let you know if it's right in a minute. Anyone else got some opinions, or do we think that's right? Maybe another couple of minutes because we've got plenty of time today. The more you take part in these, the better things are, the more you'll enjoy it. Certainly, the more you'll learn. So Sebastian thinks Apple came out before Microsoft. Nice little summary from Marcos there. So Alan Turing, Grace Hopper, developing COBOL. You put that before the computer chip. Jack Kilby and Robert Noyce down in number 3. Introducing computer chip. This is all good stuff, people. Both Steves, Bill Gates. Oh, we're getting some different answers in here. That's good. Matthews. Okay, Alan Turing, a computer chip. Grace Hopper, Bill Gates and Paul Allen falling Microsoft. Steve Jobs and Steve Wozniak, Apple, Wi-Fi. Mozilla, and then the Apple Watch. Very good, people. Okay, so let's give you some answers on that then. Okay, well, I can tell you some of you are spot on and some of you are slightly out. Okay, but it's all a good exercise. It's good fun. So the very first thing was Alan Turing presented a paper on computer numbers. Okay, that was done. That was pre-Second World War. Certainly pre-Second World War. Alan Turing was also famous for something else, wasn't he? A bonus point for anyone who can tell me what Alan Turing was also famous for and what he was involved in during the Second World War. Enigma machine. Yes, well done. He created a machine that basically cracked the German Enigma machine. Indeed, this is considered to be one of the very first practical uses of a computer system, an electronic computer system. Because, of course, we all consider computer systems to have originated potentially from essentially punch cards that were used on looms, that were used for basically creating things such as carpets. Okay, and there was punch card systems that were essentially what they consider the first program, but that's a bit tenuous in the history. Okay, number 2 was Grace Hopper developing COBOL. So COBOL was actually a programming language that was used before the computer chip was unveiled. And we used to use things such as those big old-fashioned light bulb type things that you see in the movies before we invented computer chips. Okay, then number 3, definitely the computer chip was unveiled. And the computer chip really revolutionized things because the computer chip allowed us to go from rooms full of computers to a slightly smaller room full of computers. Okay, allowed us to scale things down because the chip then allowed us to create things such as our personal computers. Now, that was when personal computers were still big and chunky. And this is when Bill Gates and Paul Allen jumped on. Number 4, creating Microsoft. Out of his garage, apparently, is where he was rumored to have started that company. Dropped out of college, decided it was a great idea because computers were where it was going to be. He started building computers with Paul Allen in his garage. After that, number 5 was Steve Jobs. And Steve Wozniak basically formed Apple, essentially as a competitor to the Bill Gates and the Microsoft end of things. Number 6 was Wi-Fi. It was developed for the first time. Wi-Fi is beautiful because it allows us to communicate over distance without all those cables. God, we don't like cables, do we? They are good for basically proving reliability, and we'll talk more about that later. But yes, the ability to communicate without wires to local systems was absolute game changer, in my opinion. And then Firefox came out, and the Firefox came out during the era of essentially what was the browser wars, where we had loads of different browsers basically getting produced. I was still at Microsoft at that time, and there was a famous phrase that we were moving literally from being operating system dependent, where we were talking about, are you running Windows, are you running an Apple, are you running a Linux OS at that time, or we moved from that's really being important, to actually just being, what browser are you running? Because the browser is going to be the key. Still hasn't quite flipped over to that. It's really important which browser you're running. Yes, but it's still not quite as key as the operating system that you're running. Bearing in mind, most of our information that we get nowadays is browser related. How many services do we have that are browser related? We run our emails off browsers. We run our internet searches, we do our bookings, we do everything. So, the browser is probably getting to be more important than the operating system. God, who still uses Firefox now? Let's have a quick show of hands. Who uses Firefox still on their systems? I say still, it's probably still pretty popular, but it's not one of the big ones now, is it? Anyone still use Firefox? Probably no one. Oh, well, I knew there'd have to be some diehard out there. Well done, Ernest. Still using Firefox. Maximilian. Yep, great. Oh, there's quite a few. Okay. At work. Good. Good, good. It's good to see that it's still about. And then, of course, the last but not least, Apple basically released the Apple Watch, okay, which then basically meant that we could start carrying everything around on our wrist. I don't have an Apple Watch. I just keep doing this just to show. Okay, so that's good. So that's the general order. Well, thank you very much for playing that little bit of entertainment with me. Okay, so let's move on then. So let's have a little look at the timeline here. So the history of computers. So 17th to 20th century was considered the early mechanical and theoretical foundations. So this is Pascal and Babbage basically getting involved in calculations, conceptual early computer design. Alan Turing basically producing his theories on mathematics and a groundwork with computation with the Turing machine. Then for the 1940s to the 1980s, we go to the 1st to 4th generation computers. And this is where we deal with generations of computers. We do with a bit of leaps. So ENIAC marketed the first electronic digital computer. Okay, transistors were used as integrated circuits, led to smaller, more compact, efficient computers. IBM Systems produced the 368. Oh, God, whoever remembered the 368? Who's old enough to do that? Probably just me in the class, I hope anyway. Okay, so IBM Systems produced the 368, establishing a particular compatibility standard. And that was what it was all about. Lots of people were producing different things and going nowhere with it. IBM said, let's have a 360 computer. That allowed us to produce certain standards, which then made things very compatible with each other. And then finally, microprocessors brought about personal computers like the Atari 8800. Wow, and the Apple II. Very nice toys. And in their time, I say. And then in the 1990s to present, okay, that's the internet era and beyond. This is where we are literally dealing with wider communications and allowing that end of things. So it's rumored, well, this is the current belief anyway, that there's a bit of dispute every now and again against some of this stuff, that Tim Berners-Lee basically invented the World Wide Web. Okay. Moore's law drove rapid advancement in processing power and technology. Moore's law is basically observes that the number of transistors in an integrated circuit doubles about every 2 years. So you can see we're beginning to talk about an exponential growth in terms of the power and the speed of our processing. And then we, of course, drop into things such as our modern computing, which includes smartphones, cloud computing, and the Internet of Things. So when you ever see the words IoT, that's the Internet of Things. And those are literally all the small bits and bobs that we kind of throw into that environment that we kind of like to give them a bit of a definition. So these are the small Internet of Things that carry out different things. Internet connected devices. Again, feel free to ask any questions as we go along. So that's kind of the hardware end of things. Let's talk about the operating system timeline. 1969, Unix was developed. As a bonus point for anyone who can guess how old I was in 1969. Single digits, let's go that way. It was a single digit number. So Unix was developed. But Unix was an operating system developed by a group at Bell Laboratories. Okay, later on, the Linux operating system will be developed based on Unix. Kind of weird. What literally happened was Linux was created, or Unix was created by Bell. A couple of really bright guys basically smashing it and doing great. But it was kind of that era where everyone kind of went, oh, we want it to be free. Why are they charging us fortunes for this sort of thing? So a couple of the developers off of that kind of went, we don't want to work for this big evil corporation. So they kind of left and said, what we're going to do is we're going to take our knowledge and we're going to build Linux. And they said, well, everyone can have Linux. It's free. And everyone can do what they like with Linux. So they basically created the first open source operating system. And nowadays, the vast majority of internet websites are basically serviced and run on a flavor of a Linux products. So in 1975, we said Bill Gates and Paul Allen basically produced Microsoft, or at least formed Microsoft. 1975, only 1 year before Steve Jobs and Steve Wozniacki came out and did Apple. Okay, so they were pretty close in times. Stephen will tell you Microsoft was first because he's a Microsoftie through and through. Acorn released some stuff in 1981. That's the IBM released the first personal computer called an Acorn using MS-DOS. MS-DOS disk operating system, that stands for very first disk operating system. Well, before that, we weren't using disks. We were using some disks, but it wasn't run very well. So disk operating system. 1984, Apple Macintosh released featuring an operating system with a graphical user interface. This is often referred to as a GUI. So it wasn't until 1984 that we weren't looking at a text-based system. Everything before that was simply lines of code, text, information like that. And it wasn't done in a graphical, it was done horribly. It was beautiful, but horrible. And then they produced a graphical user interface. And then Microsoft followed that up pretty rapidly with the Windows operating system, which also featured a GUI. Okay, and basically that's in its response to Apple. Why do we have GUI? Why do we have a graphical user interface? Because it's easier to use. We like driving things with the mouse. We like to click on things. We like to see a visual cue to what we're doing rather than having to write lines of code to get the system to do things. And there is obviously a big dispute that goes around that end of things that we probably shouldn't get into, which is about the mouse, who developed the mouse first, who should be suing who about developing a copy of a mouse, or who should be suing who about GUI. I remember sitting at Microsoft while all this was going on, being quite entertained by it all. Very good fun. Kept the lawyers employed, that's for sure. Okay, and then just to back that up, we can talk about processor timeline. Now you see a lot of this stuff ties in together. So Intel was founded 1968. Okay, Intel is an American multinational semiconductor company, which allowed us to create the first CPU, the first central processing unit. 1969, AMD was founded. AMD essentially produced a different set of chips for the Intel. Intel followed that up with an Intel 8008. 8008. Here's a question. No, we won't ask this as a question because no one younger than me is going to know the answer to this. So an 8008 microprocessor introduced in 1972 was an 8-bit microprocessor. So it could process 8 bits. Ooh. Nothing compared to what we do now, isn't it? Had a clock speed of 200 kilohertz. We're not even talking megahertz, 200 kilohertz. In 1978, then, Intel produced the 8086 processor. Okay, that was the first 16-bit microprocessor. Made a significant milestone in computer history. The first processor in the x86 architecture laid to be a foundational model. This basically meant they could then build and build and build. That was a 16-bit data bus. Whoa, 20-bit address systems. Okay, and a clock speed, wait for it, between 5 and 10 megahertz. Okay, it's widely used for a lot of the early computer systems. Then we had the 286 processor, and the 386 processor followed on from that. And that's again where we made leaps and bounds in terms of our processing power. So the 286 allowed us to do 16 bits with the 24-bit bus, and the 386 allowed us to finally get to 32 bits, still with a 32-bit bus address size. And again, as you can see, over a number of years, we're making leaps and bounds in terms of our computer power, our processing skills. So there's always been a bit of a rivalry between Intel and AMD. Apple are now producing their own microprocessor chips as well. Okay, and obviously if you go to bespoke systems, yes, you can get special chips for special environments if you need those. But they tend just to be those main two chip processing manufacturers. Still very much true today. Then we talk about storage. Oh, crikey, have I got any of these? I don't even think I've got any of these lying around. 1950, everything was done on. Oh, look at that. It's a beautiful picture there. Is that one of the first computers getting loaded in? Don't. My dad used to work at the Met Office. Had one of the big supercomputers in there. Entire rooms full of the thing. So tape drives, yes. You know, we've all seen Austin Powers, haven't we? Crikey, everyone's watched the Austin Powers movies. Everyone's seen some James Bond, where they're relating to that sort of, 60s, 50s, 60s, 70s environment. And you do see those massive tape reels that are stuck on the side, and they run tape from one to the other, spinning round. Those aren't lies, those are reality. That's how computers used to get their programs and their data from the system. It used to be on massive tape drives. I remember when I was younger, one of my friends started working at the Met Office, and his entire job was literally to take those tapes on and off of the system. And you get a little message come down and be, oh, we need tape 258 loaded onto bay 75, and he'd quickly pick it up and he'd stick it on, feed the tape through, press OK, and then it would start loading the program through. Yes, archaic stuff. Wasn't until 1956 that the first hard drive came out, first hard disk drive. Hold on. Why have we got hard disk drives before floppy drives? Yes, because they were invented before floppy drives. They were extortionately expensive when they came in, so they weren't that popular. So the first computers I ever really worked on were twin floppy disk drives. Oh, look at that. And they were the big 5 1/4 inch floppy disk drives, not even your little 3.5 inch ones nowadays. I don't know if anyone's got any pictures of those sort of things, but crikey. But if you look back in history, even before the 5¼ inch floppy disk drive, the old mainframe system, the DEC VAC systems. God, now I'm talking times, aren't they? The DEC VAC systems had 8-inch floppy disk drives. That's like 8-inch floppy disk drives, guys. Okay, and then we kind of cut them down, put them into PCs and get 5¼ inch. I remember the 5¼ when a Marcos. Yes, it's good. So as you said, hard disk drives, 1956, developed, floppy disk drives. Oh, Doom. You still run that? Look at that Doom. Who remembers Doom? So that's the 3.5-inch floppy drives. That's the tiny ones. God, we dreamt how good they were. Bearing in mind, okay, the first floppy disk drive, the 5¼ inch floppy disk drive, originally held virtually no data at all. The first original one was 360 kilobytes. All right, kilobyte. We're not talking big, are we? Then they went up to a maximum of 1.2 megabytes. The 3.5-inch floppy drives went, wow, we can do loads of that. They went from 720 kilobytes to 1.4 megabytes. Wow, we're not talking loads. I used to load Microsoft Excel on when we started PCs, on 2 3.5-inch floppy disk drives. You had to put one in, it would load that piece, you'd have to click it out, it'd say insert disk 2, put it in, it would whir around, and it would load up Microsoft Excel. And then if you wanted to do something complicated in Excel, it would say, oh, can you please put the first disk in? And you'd swap the disks while you're doing some calculations. So the fun we used to have. Okay, and then 1982, CDs came about and started revolutionizing things because they then were basically capable of holding 650 megabytes. A lot of them were only read only. So you'd write once and then you'd read from those. And then we ended up, well, solid state drives were actually developed before CDs. So we had SSDs before CDs, but they were expensive. You got to remember, a lot of why we're not using some of this stuff earlier on is because of how expensive they were. The technology was there, but the manufacturing process to put my teeth back in, to create SSDs at an affordable price wasn't available in the 1980s. So we didn't use them. Okay, that kind of brings us to the end of that small piece of history for you. We've got a little question for you here. Which of the following happened first? Microsoft was formed, the Unix OS was developed, Wi-Fi was developed, Apple was formed. Oh, look, we've got a couple of really quick ones in there. Edelrad, Matthias, Folio. Okay, there's a lot of us basically saying B was first. Yep. Yeah, we're all cracking that one through. That's good. I'm glad you all paid attention during that little bit of history for me. Yes, definitely the Unix OS was developed first. Good stuff. Any question? I'm not expecting them to answer this, but please do. Any questions about the rough history of how things go in the computer industry? If not, whoever had a BBC microcomputer, they must have come out. Oh, when did they come out? They must have been 80s, late 70s, 80s. I remember having one as a child, loading games up with a tape drive, a little cassettes, if you remember what cassettes were. Yeah. Do you have a question? Marcos, far away. All ears. Do you want to happy to type it into the live chat? We're going to see Marcos is typing a question. Yeah, that's fine. We've got all the time in the world today. We've got a very relaxed lesson today. So more questions is great. Tintan B, spot on, well done. Unix was first operating system, essentially. Does anyone, while Marcos is typing something, Does anyone recognize? Oh, is it going to show properly what one of these is? Punch card. Look at that. Masano, punch card. Beautiful. We'll have a little conversation about punch cards after we've had a chat with Marcos. Uh, there was a computer we used to have, an Intel 8088 with 4.7 megahertz, and I remember correctly. And there was a key in the desktop. Yes. Yes, they did. You used to be able to lock your computer literally with a key in the desktop. What fun that was. Nowadays we have passwords, don't we? Usernames and passwords. Punch cards. Okay, I've got loads of these punch cards. And to give you an idea, the reason I've got loads of these punch cards is because my mum and dad worked at the Met Office. So we were predicting weather. They used to put holes in these, and that used to be the computer program. They would punch holes in these, and when you wanted to load a program up into the computer, you would literally take a stack of these that had all the computer program punched into the holes. You would put it onto essentially what you would consider to be a scanner now, and it would read them in one at a time. And that would be your computer program. And that's how programmers used to produce things. No tapes, bits of card like that with holes in, telling the computer how to work the calculations. And this is why it's not, my mum's going to kill me for this. This is why the weather predictions when I was younger were absolutely rubbish. Okay, it's not true actually. They did some good weather predictions, but you can see the computer power that they were trying to use to essentially calculate what is a complex model of a weather system. Okay, so we're going to drop into another discussion question before we introduce you potentially to our first break of the session. So a quick discussion question then. So think about the last times you used a device to get information. How did you access the information? What was the device you used? Feel free to smash it up in the live chat. Don't have to put anything embarrassing in their place. Smartphone from Paul. Yeah, so we're using smartphones. Mobile phone, smartphone. If everyone puts a phone down, I would not be surprised. Smartphone. Just now, laptop. Good to see you're in the present, Ronald. Well done. Mobile phone. And what stuff are we accessing? What are we accessing on our smartphones? Seth's got an interesting question there. Like a plant you water and it grows, put in data and get data information. Yeah. Phones, browser, punch card. Locations, yes. Where are we located? I mean, what information is there we cannot get on our smartphone? If we look at it 10 to 15 years ago, probably a bit longer than that, and these were like bricks. They weren't even smartphones. I used to have to carry one of these around. It was like carrying, everyone knows what a big 12-volt car battery looks like. That used to be called a mobile phone. It was about that size, and you used to pick it up and carry it out of your car. And it would have an old-fashioned handset with a cable running down. That was a mobile phone in the old days. Absolute hilarious compared to what we have now. So what can we do from our electronic devices nowadays? Asking how to lose weight. Precious, you don't need to lose weight. You're always amazing. We can access everything. We can access everything from our banking, our job applications, our banking, our social media sites, all our communications formats, booking holidays. We can do basically everything from these toys, can't we? We can order our shopping. God, I mean, You guys work for Amazon. I mean, I use Amazon. I probably use it more than a lot of you guys do, the amount of orders I place with Amazon. So yes. So mobile phones took 17 hours to charge and 5-minute talk time. Yes, they were very much like that, Paul. Thanks to battery improvements and things like that. Yes, and the microprocessing advancements we've made, everything is becoming smaller and smaller. Wrist devices are now basically in, aren't they? So I don't even have to carry a phone now. I can simply do the lot from this if I wanted to. Rubbish communications, but and I look a bit silly walking around like this all day. Google search. Okay, that's good. So that kind of runs us through a little bit of the old history of IT, how it was, what it used to be. And I really think everyone should appreciate the pain that I had to go through when I was growing up with no mobile phones, no communications, going to the phone box to phone my friend. Wasn't quite that bad, but you know what it's like. And now we boomed. Everything is growing. And the reason I mention that is because history is a reflection of what we have in the future. So in the future, we're going to see similar expansions. We're going to see similar booms. We're going to sit here. We're going to sit here in about 10 years' time and laugh at how big our mobile phones used to be and how cumbersome they used to be. Probably as it all develops into wearable, we'll have them inserted in our arms, flat pads, multi-screens, VR headsets, just little glasses, and we'll be laughing about, oh my God, we used to have to carry that really heavy iPhone around with us. How ridiculous was that? Well, we're doing that now about the old phones. We'll be doing that in the future. But it is a really exciting industry, and I'm glad you guys have chosen to come on this course to get into that industry because it is always going to expand. It is always going to be exciting. Okay, and on that, we'll introduce you. We tend to do these sessions tend to break into we do the first hour, then we'll have a little break with a bit of music. Gives us a chance to refresh. We'll get a coffee, an apple and a banana, I think is what I normally ask people to have if they get it, or a comfort break. We'll have that for about 10 minutes and then we'll pop back. Sometimes we might shorten the length of that break, depending on the topics that we need to cover and how much we need to cram into that 2-hour sessions. Phone booth, yes. Okay, so I hand you on to Rasha. She's going to play some banging tunes. And we have a 10-minute break and we'll be back for well, I'd like to say 6 o'clock, but there's all different time zones around here, isn't there? I will not say that. I'll just say back in 10 minutes. There will be a timer on screen for you. Well, welcome back, everyone. I need to remember to start my video. How are we doing, people? Okay, so welcome back. I hope you've all managed to get a coffee, an apple, pancake, or comfort break, or whatever it is you needed over those quick 10 minutes for you. So we're going to begin the content. So let's see. Princess stepping her front there, isn't she? Let's see. Thumbs up for everyone who can see the IT roles and responsibilities slide. Just to make sure I'm showing you the right bits, that is. Wow, perfect, Peter, Dashiell, Sebastian, Ronel, Marcos. Keep the questions going, as I say, through the course and the content. More questions, the more you'll get out of it. Okay, I'm always happy to drift off the topic if we need to, and we can always divert that and we can pick it up later. But always better to have more questions. Okay, so now we're going to dive into essentially the roles and the responsibilities. So IT, okay, it's the devices such as computers to access information. We kind of went through that. Allows us to create processes, store, retrieve, and exchange a variety of data and information. There's a plethora of roles that you could potentially do within IT. Okay, so it's not just based on a particular industry. The main responsibilities of IT support specialists is to manage computers and networks, store data, and provide technical support. Some of the roles, I'm going to read them all out because there's loads up there. IT support specialist is probably one of the prevalent ones, okay? You might get a first line support job, second line support job. You might become an application engineer, as a guy who may well be designing the applications. A computer programmer, obviously where you write code. IT coordinator, IT director, IT network specialist. I wouldn't think we're going to drop into IT security specialist or IT director straight away, but those are certainly in the career path that you could basically get on. Network engineering. If there's any of you keen to basically become network engineering, this content of this course will give you a good foundations to step into those positions or continue further training to get those sort of qualifications that will then push you into those locations. Quality assurance, QA tester. Okay, QA testers are the guys that essentially, if some programmer basically writes a fantastic program, creates a beautiful website, the beauty, and I'd love doing it, the QA, quality assurance tester, is the guy that then breaks it. His job is to sit there, his or her job is to sit there and attempt to break that system, find faults, find errors. A lot of that is done through automated codes and automated tests. But yeah, that's the sort of person who breaks the systems that the programmer then creates. Again, software engineers are in there, support specialists, which is a key role, very important for keeping the businesses running. UX, so user experience designer. These are the people that design the web pages, the front ends that people look at, which is all about the user experience. And it's very important because if your website is rubbish and horrible, people don't use it, and then you don't get the sales. So looking at that list, has anyone got any particular targets where they'd like to go? Any particular roles? Please smash it into the live chat if you have a particular target that you're looking at, or a particular position you have in mind when you've completed this course. Caliban is number one, IT support specialist. IT support specialist for Edward. IT help desk support. There's a lot of crossover between those two. Yeah, definitely. Security specialist. Security's still out there. There's lots of good roles in security. So this is a step up, but it's definitely a great grounding we give you here for the security specialist. IT security after more training, Paul says in there. Well done. Quality assurance tester. Zachariah, have you one of these people who's got a bicycle at home or something like that that's in bits where you took it apart trying to break it and you can't work out where all the bolts go back in? I was pretty much like that when I was a lot younger, for sure. IT coordinator is a good position. Network engineering. Oh, these are the fun guys, network engineering. Yes, there's a lot of good stuff, certainly in data centers for network engineering or in big corporations. You've got to love chasing cables. I recommend you get yourself small hands. You've got small hands, you can do it. The amount of times I've had to reach through network cupboards to try and find where cables have basically gone and try to follow because they're all the same color half the time, trying to follow the same colored cable out the back, around the side, up the back, trying to trace where the cables go. Good fun, very good. Web administrator. Oh, web administrator, software engineer. Freshers, very good target. Be very good if you can do that sort of thing. Mateus is extremely interested in the UX in my school for years, but currently IT support or network engineer. Keep UX in mind. Yes, it's definitely a role that you could develop into. Certainly something you can jump from IT support specialist to UX engineers. Luca's just going to do all the jobs in the world, aren't you? Great stuff, Luca. It's good to have some ambition. Well done. Okay, so there is some overall responsibilities. Providing technical support and assistance is done via email, chat, phone, in person. God, we have walk-ins and things like that, okay? And your job is really to resolve issues. So we'll talk about some of those things. So typical IT tasks that you get into, troubleshooting technical issues, yes. So we're talking about break fix, we're talking about identifying and resolving hardware, software issues that the users basically encounter. This involves a lot of analysis, error messages, system logs and diagnostics, or simply knowing what the user is basically talking to you. network configuration and maintenance. So this is where you end up designing networks, creating the settings, dealing with firewalls and router, dealing with those types of configurations to allow traffic through, and more importantly, to stop traffic. It's all about denying everything and then allowing just the pieces that you basically want to come through. Software installations and updates. Yes, if you work in a big company, there will be specific jobs and specific persons that are in charge of just doing software installations and updates. Okay, it's all about designing and making sure that the software is updated and relevant, but also that that software you're installing isn't going to break some other system. So upgrading the operating system isn't a case of just going, yeah, fine, we'll have the latest release, that's great. Because if that latest release isn't compatible with a web application that you're running, you don't want to put it on there because it's going to break it. So you have test environments for that. It's a very interesting role. Backup and recovery. Yes, we'll talk about backup and recovery implementation. Not, I'd like to say it's not that interesting. It can be interesting, it can be fascinating. It's really about processes and making sure processes are stuck to, and that you are backing up and able to recover. Backups are only as good as your recovery process. So backing up and recovering those particular data. And cybersecurity monitoring. Yes, there is a whole plethora of companies out there that do what is known as SOC, security operations centers. And they deal with all cybersecurity monitoring what's going on in other people's estates, looking out for error messages, looking out for multiple logons that could be suspicious, looking out for breaches, so pen testing, and vulnerability scanning. So basically tells them where things are basically incorrect, where things aren't up to date, where vulnerabilities could be, where a hacker or someone with malicious intent could potentially get in and either steal data, corrupt data, or cause all sorts of cyber security issues. I don't know. I am. Someone's going to have to help me with that name. My apologies. You say doc attack. We'll have a chat afterwards so you can help me pronounce that. I can't keep getting it wrong, can I? Doc attacks, you mean doc or DOS? DDoS attacks, things in there. Defense and intrusions, cybersecurity, yes, definitely. So there are a lot of good cyber IT tasks in there. And we tend to divide, certainly, if we talk about technical support and things like that, we tend to divide it into two particular categories. There's what is known as a help desk. Okay, so a help desk is normally an internal to your company. So a big company like Nats or something like that will have its own internal help desk that it runs. That means its people will phone its internal people, and that is internal support. Or external support tends to be done by a third party. Microsoft has external support. If you use a Microsoft product, Windows, Office, or something like that, you can phone Microsoft as an external customer and talk to their support about their product. So that is external support. So we make a bit of a definition between the two of those. Internal, it's all within the one company, not going elsewhere. External, someone like Microsoft is providing software or a service, and someone external is phoning their support desk to get some information. So here we go then. So quick discussion question. So suppose you call customer service to help you with an internet connection. Is the specialist you're talking to part of an internal or external support team? Oh, look at that. Fastest fingers first coming up there. Well done. Majausi, Sebastian in there, Paolo, Prince, Mateus, Cablan, external. Wow, we're all cracking through. It's good to see that you're getting these ideas really easy. Yes. So that is definitely an external support because it is a service offered by a third-party company. Great stuff. See if a couple of you smashing some details in there. So they all look pretty much the same. So whether you're dealing with internal or external side of things, a help desk or an external thing, you tend to provide assistance on a one-to-one basis. You'll get one ticket, you'll get one telephone call, you're speaking to one person, okay? All the services are monitored. So there's a service desk that is monitored service in terms of the queue that it comes in. And we talk a lot more about this later on in the content. And there's preventative maintenance checks that go on in terms of making sure things are up and running, maintenance and self-help content. So we all basically know, I mean, every time I go to something like a banking app or we go to a booking system, there's always a little self-help, isn't there? Microsoft has it as well. If you go onto the Microsoft website and go, I'm having problems with this, first thing it does is it directs you to a self-help. Is it something like this that you got problems with, sir? Before you then end up raising your ticket and getting online. Some things you're likely to be doing in there are things such as resetting network or application passwords, unlocking account if someone's managed to lock their account, re-imaging hardware. Much as we love the hardware we run on, whether or not you run on a Mac or a PC, every now and again it's one of those things. Every now and again you would just go, let's just re-image the hardware. Let's get rid of anything that could be causing problems and just blow it away and put a new system on. So much easier nowadays because all our data no longer lives on our laptops, does live there as well, but tends to live on the cloud. So I can re-image this piece of hardware. Takes about an hour or so, connect it up to the internet, and all of a sudden, strange enough, all my data is still accessible. So it is a lot easier now to re-image system. We also now, since COVID and probably before COVID, I got the amount of IT directors I had conversations with about why are we working in the office before we hit COVID, and now all of a sudden we're not working from the office, was incredible. Okay, we can, with the IT systems, we can work remotely or on site. So we have options where we work. I don't know who's got that one.
How to create a Microsoft account. Then
Can someone who's turned their microphone on turn it off? Thank you. Thank you very much. We won't name and shame anyone. That's fine. So we can basically deal with things working remotely. I used to work with some developers who developed an application for us. They were in Australia, and there was one guy in New Zealand. I didn't care where they lived. I didn't care where they sat, because we're in a global world now. I can access people's systems remotely. I can fix them remotely. So we don't have to be on site. We don't have to be walking up, touching people's computers and fixing things. Sure, it's great to have walk-ins because it cheers your day up and keeps you doing things. But we no longer have that legacy of having someone to have to walk into our room and go, oh, my computer's broken. Can you please come and fix it? Because they can pick up the phone, message us. Well, probably not message us if their computer's broken. And we can do it in that particular manner. So we can work remotely. There's some common tools that we basically have to do that. Things such as video conferencing. Yeah, we're doing it now. We're doing it on Zoom. We're having some good chats. Certainly, modality. Hardware issues, yes. Hardware issues, you will tend to have to wander around and touch things. Yeah, definitely. Software issues is where a lot of the problems called. A lot of the hardware nowadays is fairly stable, so it's not a mass of it, but definitely it does happen. So common tools that are used. Okay, video conferencing allows us to have video conferences to chat to people about issues. ServiceNow does things like service desk management and service management. This gives us beautiful wallboards to tell us how our systems are performing. Wide area networks, how's that performing? How's our Linux estate performing? Zendesk is a common ticketing system. Okay, so Zendesk manages our tickets for us, so we can automate that. And of course, we've got our beautiful cloud computing, such as Google Cloud, AWS. Storage and shares are out there. So, you know, don't worry if you're not familiar with these tools. We'll basically have a look at them later on in the course. But probably now it's a good time to have a little look at the course overview. So I know you kind of had, we should have a rough idea of what we're doing. This kind of gives us a little bit more detail. So this is what we're going to be talking to. Here are some of the topics that we're basically going to cover. So we're going to cover computer hardware. We're going to cover some of the software basics. We don't go into programming software, but we're going to cover the basics about software, what software does and where it is. We're going to cover our beautiful computer peripherals and architecture. These are the devices that stick on the side, cameras, etc., etc. And we're going to cover our operating systems. Okay, we're going to look at the Windows operating system, the Mac OS X, and Linux. Okay, we don't expect you all to have access to those. We don't expect the Mac users to have Windows, another Windows device sat next to them. We don't expect your Mac users to have a Windows device. We don't expect your Linux guys to basically have other ones. What we'll do is we'll provide you a virtual environment that you can go into and you can play with, stroke break, them as much as you like without affecting your local machine. And all you got to do is hit a reset button, and strangely enough, you'll be back up and running with the system again. And again, you can try to break it again. So we'll give you the access to those operating systems. Now, Mac is a strange one. I don't think we can get, I don't think you're not licensed to run a Mac OS X unless it's on a Mac machine. Okay, so that's one of the fun things. So we'll talk a lot about the Mac operating system, but we won't be able to give you any play pits for those to play on. We will also talk about troubleshooting techniques. This is one of the key pieces for anyone who moves into an IT service desk position, computer support specialist. Yes, troubleshooting techniques are key, and we'll give you a very good grounding at that. We'll talk about our mobile devices. Yes, I get to wave my phone again. Yes, our beautiful mobile devices, configurations, how they are, and what they can and cannot do. We will talk about our networks. We'll talk about wide area networks, local area networks, Wi-Fi. We will discuss around networks and we'll give you some great ideas on networking. And we'll talk about personal and business security. We do separate those into two separate lectures because personal security is different from business security. There's a lot more integrated stuff in business security and it covers a wider aspect. We're going to cloud computing. Yes, we love cloud computing. It is a beautiful topic to cover. I love covering it. We will go into cloud computing and we'll discuss what it is, all the terminology, and we will cover that in a certain amount of details. And we'll drop into things such as ticketing system. Again, a great piece of work if you want to become a IT support desk, help desk person, move into computer support specialist. Yes, ticketing systems you will need to understand. We'll talk about the flow of ticketing. We'll talk about other items such as that. We'll talk about professionalism. Okay, this is how you behave. You got to remember one of the critical things I always notice about working in IT is as soon as you step into IT, all of a sudden everything is open to you. If you work in an IT department and you get fairly high in an IT department, you have access to everything. So being professional about it, you have access to people's pay because you're in charge, strangely enough, of the account systems. You're in charge of the HR systems. So you, not to mention all the financial records, etc., etc. So there's a definite amount of responsibility and a definite amount of professionalism that needs to basically be happening. And if you're on the first line support desk, help desk, you are quite often front line for that company. It's what people see. Someone phones Microsoft and speaks to a Microsoft representative, that frontline support guy is representing Microsoft. So you've got to be professional in those environments. We'll crack some remote support, how we do it, do's and don'ts of that. We'll talk about some virtual machines. Virtual machines is not just about cloud computing. We'll talk about virtual machines. We will cover backup and recovery. And I'll constantly say your backup is only as good as your ability to recover that data. And we'll go into some details on that. We will also drop into the future of IT. So we'll have a good chat about what could be off in the future. Good. Any questions about what we're going to cover before I kind of slip into the next topic? Does that kind of cover the stuff that you're all expecting to? Thumbs up if it does. Add a comment if you think, you'd like to cover some things or you're here for anything particular. Marcos, do you have a Windows machine and a Mac? Cool. I'm going to ask a horrible question. Which one do you prefer? MacBook's old. Yeah. I think it's one of those interesting things that Apple did was PCs were cheap and Apples were expensive. Apples were better, yeah, sure, but they were expensive. Mostly Windows. Yeah, that's fine. It's good. Well, you'll be great at doing some of the CompTIA tasks that we have for Windows. Maddie is curious about ticketing systems. As I don't have any idea, yeah, we'll cover you. We'll hold your hands through that and we'll introduce you to ticketing systems and how they manage the flow of tickets and what benefit they are for companies. Good. So now we are going to drop into the course assignments. So there are some assignments. Rasha's going to correct if any of these are incorrect, aren't you there? So you're looking nervously around. We have 3 mini projects that we give you, and these are fun mini projects, but they are sort of graded. So these are things you kind of go away. We give you a bit of a task. We say build this particular network. Not to build the network, but draw diagrams for this network, and off you go. Bring it back to us, and we'll have a little look through it. So we'll do 3 of those. We have 3 quizzes where we kind of give you some questions and answers. And we'll give you a certain amount of time to basically get those. Those are weeks or something like that, isn't it, Rasha? We don't kind of go straight away, off you go, please answer this now. So we do that. So we give you time to complete these items. They're not long stuff. So don't think you're going to be taking days and days to produce these. They are some good quizzes. They are very targeted, as are the mini projects. And then we have 10 labs that we basically go through. So that's 10 little trips into CompTIA. We'll introduce you to CompTIA in a little bit, where you are asked to go in and perform some virtual sessions. And we have a little play. These are essentially a big sand pits for you, is what our labs are. And you can go in, we can set you some tasks or give you a list of things you can do. And you play with the operating systems, or you play with the ticketing system. You play with a variety of items, and that helps you understand things. Sham asks there, are we going to learn any configuration techniques? Yeah, we'll talk about some configurations for Windows, Linux, and the Mac OS X. We'll talk about that. We'll probably talk about configurations for networking and security configurations. We'll talk about some firewalls, lightly, routing, and all those entries. So yes, we will talk about those items. Any questions about the course assignments and little things like that we'll get you to do? Don't be scared of them. That's the biggest thing. I'm going to say they're easy, but that's because, you know, I write most of the questions, so they're going to be easy for me. They're not impossible. I'm not cruel. Okay, let's drop into quick glance at CompTIA. Okay, so CompTIA is an online platform that basically allows us to integrate a development environment, so a play pit, where you can basically do some coding, programming. We tend to use it for virtual machines. And when you drop into CompTIA through your training portal, you will find a set of labs. And the labs you will be able to access, and they will have instructions there. So you can see that you have an introduction to the lab that will tell you some details about the lab. And then you have an activity overview, and then we'll give you a set of steps. So it's kind of a handheld step-by-step that will say, go into the control panel, change this particular item, see what it does, and we can carry out those little items. Okay, so we will hold your hand very much when we get into this and we start using CompTIA. Stefan will basically be running most of the CompTIA sessions. He's excellent at that, and he will talk you through it. And these are available for you. So if you don't quite manage to complete it during the lecture, they'll still be available later, and you can kind of play with them. They don't stay forever, but they're available for a certain amount of time for you. When I say a certain amount of time, I think it's a week or so for each, or probably longer, depending on what we're doing with the CompTIA at the time. So you will have plenty of time. So if you don't get it done in the lecture, you get another, you get a bit of time tomorrow or the day after, you can drop in and kind of go, pop through it, And if you do really struggle, then yeah, I mean, we can have a chat with a teaching assistant and you can get some time with the teaching assistant, book that in and hold your hand through it all and make sure that you can do the tasks that we ask. Any questions about CompTIA? It is a virtual environment. So we are not asking you to install anything onto your machine. We don't ask you to break any of your machine settings or anything like that. It is simply a web-based. So as long as you can get on the browser, I think we prefer you to use Google Chrome to get access to it because it's one of the more compatible browsers. As long as you can use Google Chrome, it's like accessing any other website, but with the virtualization environment in there. Good. Any questions about CompTIA? Give me a couple of seconds just to type anything if you wanted. Edard asks there, is using Chrome a must or are we allowed to go with other browsers? Yes, it's not a must. Okay, we advise you to use it because we know it works with it. Okay, that's why we test it. That's why we do all our programming for it. Potentially you could get in with a Firefox or with an IE or something like that, or an Edge Explorer. Yes, you're welcome to try it. I mean, we're not going to force you to do it, but the general advice is, yeah, if you can, just download Chrome, use it with Chrome. That way it will save you getting to the point where we're kind of going, let's do the CompTIA stuff. And you sit in there going, Dave, I can't get in because I'm using some funky version of Firefox. Sebastian asks, it works on any platform or is it compatible? We don't care what operating system you use. It's a browser. So as long as you can get Google Chrome installed onto your Linux, Mac, PC, your little, what do they call them, Chromebooks? They used to have Chromebooks. You can run it off a Chromebook if it's running the right browser. Okay, we don't care about the operating system. Great. Any other questions about CompTIA before we drop in? Good stuff, people. Good stuff. We're doing really well cracking through this course. I'm enjoying the start of it. So theoretically, we can use it from a smartphone. If it's running the right version of Chrome, theoretically, yes. Would I want to use a virtual environment on a smartphone? I don't know how big your smartphone is, but mine's only a little one. I only like a little one because that's what fits in my pocket. So, you know, potentially if you're using a big one, yes, you could. Would I advise it? You're probably going to lose a bit of it because you probably need keyboard access as well as mouse access. And it's, yeah. I have to wear glasses already for driving. I couldn't do the lot off a phone. Worth a try. Tis, yes. Do it from an iPad or something. Okay, so part of what we target this course as, got a couple of questions. Are we trying from an iPad? Okay, Sebastian. Try and get it checked before we dive into it, but yeah. Good news, we can use a Chromebook. Yeah, as long as the Chrome version on the Chromebook is compatible, yes. So it should be fine on that. So as I say, part of what we are targeting, it's not a total target. Part of what we are targeting is the CompTIA A+ certification. Now, we do target very much the content of that course and that exam qualification, but we do cover some additional pieces around the side. Okay, because it's unfair just to go, we're going to do CompTIA A+, because that doesn't give you what I would consider to be the best foundations for them moving into the right job. It is a good industry standard qualification, and that's why we target it. So a CompTIA certification, it's a globally recognized certificate. Okay, it's a foundation skill in IT knowledge and IT support roles. So they say that the career path basically is IT help desk, data center technician, business analyst, IT server technician, field service. So you can see a lot of those things basically match what we are basically doing. MSP personnel is a managed service provider personnel. So anyone who's managing a service for you. So the jobs that it basically targets are pretty similar to the ones that we have. So to give you a rough idea, CompTIA A basically breaks it into 2 exams. They have a core 1 and a core 2. They give them some beautiful numbers, which we ignore as much as we can. The first topics cover mobile devices, network technology, hardware, and virtual and cloud computing. Core 2 covers the operating systems, security software, troubleshooting, and operational procedures. Now the passing score, 675 out of 900, 700 out of 900. Yep, we can all manage that. It's not really going to be super tricky as far as I was aware. Total questions is 90 questions per exam, 90 minutes. So you've got 1 question per exam. We'll go into some more details later on because we do have some prep sessions. So the question types are multiple choice questions. These are well familiar with multiple choices. Is it A, B, C, or D? Drag and drop questions, where we simply need to drag particular answers across the screen into some locations. And there are some performance-based ones. These are things like modeling, where you will go in and they'll say, go and change a particular setting in the control panel. So you have to then find the control panel and change a particular setting. Or they'll show you something like a couple of computers with some IP addresses and they'll say, well, what do you need to change to allow this computer to talk to this computer? Don't be scared. We will cover how you basically do all this stuff. So we will not leave you unprepared. We will teach you throughout this course all the items you will need to basically pass those exams. Prior experience, none. Don't need prior experience to sit the exam. 9 to 12 months experience recommended. Do this course. That's probably all you're going to need. So something like a performance-based question here. We can see an example there where they are talking to switches, routers, and it's a simple configuration change. So that don't focus so much on the details on that slide there. Just focus on this is going to be what a test question might well look like. And I think this one talks about working with the executive office and who can access which particular DNS server, which particular switch. So we won't go into any details. And later on in the course, as we get closer to having to sit those exams, we will do some prep questions. We've got 2 prep sessions. I'm sure it's 2 prep sessions from what I remember. 2 prep sessions where we will sit you down and we will go, these are the type of questions, this is the sort of stuff you're going to experience in this exam. And we'll give you a hand through those. So we will make sure you are looked after. In addition, throughout this course, we will have some fun. Okay. I don't want to be boring and lecturing you all the time. I want to be having fun as well. So what we'll do is we have a product we use called Kahoot. It's a fun question system. So we'll bang it out. We will ask you some quiz questions and we will have leaderboards and we will have virtual suites and treats and fireworks and all that sort of stuff just to jazz things up. So we will make it as entertaining as possible. But remember, we're making it entertaining because it's knowledge transfer. And when it's entertaining, you will remember more knowledge. Just as I said, when you are communicating more in the live chat and getting involved, a lot of this stuff will begin and stick in your memory. Seth, what question do you have? I'm going to handle Seth's question first. Can I write the CompTIA A exam after this? Write or take? Once you finish all the lectures, we think we have given you the ability to pass the CompTIA A exam. Rasha, are you able to handle Cablans? You want to do that now?
Yes. Let me Yeah, let me clarify this point. Yeah, so uh, as part of this course, yes, we will prep you for the certification process, but the cost for the exam will not be covered within this course. So, yes, just to clarify that point.
Thank you. Well, giving us some good advice there. Also, loads of places offer vouchers on the CompTIA exams. You won't need to pay full price, so there will be some discounts floating around somewhere on the internet. This is always the way these companies work. And part of that is, it's market driven, isn't it? They know full well if they get you into doing the CompTIA A+ exam, then you're more likely to want to go and do the other CompTIA exams further on from that. I'm not going to be able to answer that one because it's going to, sorry, the question about how much CompTIA certification costs, because it's been a while since I've looked at it. I'll simply park that one. Have a hunt round, like Paul says, you'll be able to get some cheap vouchers elsewhere. A lot if you go networking, security, and A+. So really, we just need the A+ exam. That's the one we're prepping you for there. Precious. The exams are taken, you can either go to an exam center, Precious, just to answer this one. You can either go into an exam center, you can look that up locally on the CompTIA website, or you can do it virtually. You can sit at home and do it. Okay, and they have a beautiful system that tracks your eyes and your movements and checks you don't have manuals or multiple screens. So it's kind of like a watched exam at home. You don't have to do any exam, no, Marcos. Marcos asked, do we have to do this exam? No. The reason that we tend to advise you or tend to target that is because if you can wave in front of an employee that you have the CompTIA A+ exam, then they know you are at a particular standard. But just as well, you can simply say, you've sat Dave's fantastic course, and anyone that knows me will simply give you a job straight away. That's one of the thoughts anyway, Marcos. We do run to a really good standard here. And indeed, before we started tailoring it towards the CompTIA, we ran a lot of students basically through these exams, essentially through our courses, that then literally walk straight into other positions. So it is very much doable. It is a tick in the box, the exam process. Potentially worth doing, depending on how you feel about it. Good. I'm glad I got those questions for you guys. Okay, so as a bit of a conclusion then, today we kind of covered a brief history of computers, and I thank you very much. You all managed to stay awake through my history presentation, which is great, and you asked some really good questions on that. That was good. So we covered what IT is. So we covered the basics of IT and what the concepts are, and the responsibilities of the IT person. Remember, as you drop into the IT world, you gain access to an awful lot of stuff that you wouldn't normally have. And we kind of covered what's included in the course and some of the tools we've used. We didn't introduce you so much. We talked about CompTIA. We haven't introduced you to Kahoot yet, which is a comedy thing, which I love doing. Okay, so we will basically get on to using those as well. So it kind of brings us towards the end. We're here for questions and answers. Okay, please feel free to throw any questions in. We'll pick it up as it comes along. Chris has basically said you can visit the CompTIA website to register for the course. Yep. And that was Marcus's next question anyway. Well done, Marcus. Thank you, Chris. Good. Please feel free to bring any questions up in the live chat. A history question. Thank you, Marcos. Any history questions is much appreciated. The first, isn't the first ever computer the one they found in Greece? Oh, I don't know actually. It's really weird because the definition of a computer was, I don't know, it's always one of those ones that was kind of hotly contested. It's like who invented the WWW. Well, you know, we're not really sure. Was it a guy in Oxford, or was it a guy in Cambridge, or was it someone over in the States, or you know, where was it invented from? You know, we know that people like Babbage and people like that were using punch cards to do looms. So they were using good old-fashioned punch cards with different holes in, and they put it in the looms that used to make carpets. And the idea was when there was a hole, it let the what do you call it? I want to call it a dolly, but it's not. Someone might know, God knows. Literally let the threads shoot across. Shuttle, that's what it was called, I think it was. And let it shoot across. And that's how they got the patterns. So they had a set of punch cards that represented a set of patterns. So that then allowed it to produce a pattern on the carpets. So that essentially was the first ever, what we determine as a program, but first ever computer, crikey, could be anyway. I mean, you could look at abacuses and go, they're sort of a semi-computer, and they were used in China well before BC, weren't they? Thank you very much, Paul. I do enjoy giving these lectures. Around the same age. Okay, Paul. Hopefully, Paul, your body doesn't ache as much as mine does at times. Mind you, I'm still playing rugby, which is something I think my knees are regretting at the moment, definitely. Okay, well, we can wrap this up. Rasha, have you got any further comments? I know we're going to have as many questions as you like, but do you have anything you'd like to add?